It's me once again with your math solutions. In this video, we'll be talking about standard form. But before we continue, I'd like you to do me a favor. Please like this video, subscribe if you haven't, and share after watching this video. Now let's get back to business. There are times when some numbers are too large or too little that you have to represent them with a standard form. And the standard form is this format. You have a times 10 raised power n, where a is any number between 1 and 10. Okay? And n can be any whole number, be it positive or negative. Okay? So let's take, for example, you have something like this. You have 3,000. Okay? 3,000 is same as saying 3 times 1,000. And 1,000 is what? Same as saying 3 times 10 raised power 3. So this is representing 3,000 in standard form. Okay, so 3,000 is same as saying 3 times 10 raised power 3. So let's look at representing these numbers in standard form. You have 60,000 here. Okay? The same thing as saying 60,000 is the same thing as saying 6 times 10,000. And the same thing as saying so let's look at 450. Now, 450 is like saying 4.5 times 100. Okay? The same thing as saying 4.5 times 10 raised power 2. Then you have, let's count, this is let's say we have 480 million. The same thing as saying 4.8 times 100 million, which is the same thing as saying 4.8 times 10 raised power 1, 2, 3, 4, 5, 6, 7, 8. 8. So the trick is this. Whenever you're given a number to convert to represent in standard form, just start from the beginning and put a 0. Okay? Let me not put it here. Let's say start from being 1.7. Then from this place, wherever the decimal point was put, you count the number of digits. You have 1, 2, 3, 4, 5 times 10 raised power 5. That's the simple way of doing this. Just count from that place the decimal point was placed, the remaining number of digits. Okay? You raise your 10 to that number. Very, very important. So 170,000 is same as saying 1.7 times 10 raised power 5. And of course, remember that this number should be between 1 and 10. Should be less than 10 and greater than at least 1. Between 1 and 10. So let's look at numbers less than 1. Okay, you have 0.0001. I don't know if you can still remember converting our decimals to fraction. So you have, this is the same thing as saying, okay, let's say 0.0001, same thing as saying over 1, 2, good. Same thing as saying 1 over 10,000. Okay? So now, the same thing as saying 1 over 10 raised power 4, which is still what? 10 raised power minus 4. So looking at this, you have 0.00008. Okay? Same thing as saying 0.00008 over, under decimal point you have 1, under this one 0.000. So you have 8 over 100,000, 8 over 100,000, which is same thing as saying 8 over 10 raised power 1, 2, 3, 4, 5. 5, which is same thing as saying 8 times 10 raised power minus 5. Let's look at this 0.025. Okay, the same thing as saying, remember we're interested in a number between 1 and 10, so it's same as saying 2.5 over 100 over 1. Okay, so we started from here to here. This is where the point moved to, so we're taking 100. So it's same as saying 2.5 over 10 raised power 2, which is same as saying 2.5 times 10 raised power minus 2. So this is 0.25 represented in standard form is 2.5 times 10 raised power. So the easy way and straightforward way of doing this, okay, instead of expanding and everything, what I would recommend you do, you move the decimal points. As you're moving it, you're counting the number of steps it took. Okay, so like now we have 0.00082. What I would do if I'm supposed to put it in, represent it in standard form, you move it 1, 2, 3, 4. Okay, so it means what you have is 8.2 times 10 raised power minus 4. Okay, 8.2 times 10 raised power minus 4. That is it in standard form. So instead of going all through the long process of dividing and everything, just move the decimal points as you're moving it. Once you get to the first number, after the first number, you stop. Okay, and leave your decimal points there, and then you count the number of steps you took to get there. Let's look at rounding off. This is more or less like a revision, because I'm sure you should know what exactly rounding up means. That's trying to approximate a number to a certain way you desire, or something like that, or is required of you. So during rounding off, remember that numbers that end with 1, 2, 3, 4 are rounded down to 0, and 5, 6, 7, 8, 9 are rounded up to 1 that you add to the other digits. Let's take for example. So for example, if you're told to round 354 to the nearest tens, okay, you round it down. This 4 is the last digit, is the unit digit, and since it's not up to 5, you have what? You round it down to what? 350. But if you're told to round this one to the nearest 10, because this digit is more than 5, you round it up to what? 470. So we'll play a game now. Let's look at playing a rounding off game. Okay, you have to round up to the nearest thousands, hundreds, and tens. So you have 12,835. To round it up to the nearest thousand, we need to look at the hundreds digits. Okay, so here is 8. We round it up to. Round it up. It will not be 13,000. Okay, for hundreds, we look at these digits, and since it's less than 5, we'll round it down. So we have 12,800. And the nearest tens, we'll look at the unit digits, and unit is 5, so it means we'll round it up. So we have 12,840. We have 12,840. Okay, so here we have 30,637. To the nearest thousands, we'll look at the hundreds. 100 digits is 6, so we'll round it up. So we have 31,000. For hundreds, we'll look at the tens. Okay, and it's 3, so we'll round it down. We have 30,600. Then for the tens, we look at the units. So we'll round it up. This one is less than is greater than 5. So round it up. So we have 30,640. 30,640. So now for this one, we have 16,560. To the nearest thousands, of course, we're looking at the 100 digits, that's 5. We have 17,000. For hundreds, we're looking at this, and we have 16,600. 16,600. Then for the tens, we're not rounding anything because it's already rounded on its own. 16,560. Okay? Now looking at this 5555 to the nearest thousands, we're going to look at this hundreds digits. So we round it up to be 6,000. For the hundreds, look at this. We have 5,600. And for the tens, look at this, and we have 5,560. 5,560. So let's look at rounding off to whole number, tenth, and hundredth. Okay? Now, if we're trying to round this on to the whole number, 2.517, we'll look at this one. Okay? The tenth, look at the tenths. Okay? And here it's 5, so round it up. So for whole number, we have 3. Then for tenths, we look at the hundredth digits. And it's 1, so we round it down. So we have 2.5. Okay? And if we want to find it to the nearest hundreds, we look at this, thousands. And we'll round, since this one is 7, is more than 5, we'll round it up. So we have 2.52. Okay? Now looking at this one, to the nearest whole number, 3.1, look at the tenth digits, and we can see that it's not up to 5, so we have 3 again. For tenths, we have this one not up to 5 again, so round it down, it's 3.1. Then for hundreds, look at this, and it's up to 5. We have 3.13. Okay? Then looking at this one, to the nearest whole number, this one is not up to 5, so nearest whole number will be 0. To the nearest tenth, we'll look at this, it's up to 5, so we'll round it up. We have 0.5. Then for the nearest hundred, look at this, and it's not up to 5, so you have what? 0.49. Let's look at significant figures. Okay, we're going to apply the knowledge of rounding up numbers. Okay, let's take, for example, you're given a number 256.42, and you're told to round up to one significant figure. Okay, you start from the left of the number to count. Now you said one significant figure means that you take only this. Okay, now looking at this, you can see that the next number is 5. You have to round it up, okay, to be able to get that significant figure. So now you have, when you're rounding it up to one significant figure, okay, 256 is what? 300, okay, because I'm interested in just the first significant figure, and this is greater or equal to 5, so you round it up. So when you round it up, you have 300, okay? And two significant figures, you have you're interested in these two now, but then the third one is greater than 5 as well. So what you have is what? 260. Okay, it's important to know that once you're rounding up, the remaining digits become 0. Okay? Now, for 3 significant figures, you have what? We're interested in these first 3. You have 256, because this is not up to 5. Okay? Even for significant figures, you can have 256.4. Let's look at this number, for example, okay? And you're supposed to round up to one significant figure, okay? We'll take just the 8s. 2 significant figures, we have 8.0. Now this 0 is important because it still has value before it and after it, okay? Then 3 significant figures, we have 8.03. Okay, we have to round up to 9. Then for 4 significant figures, we have 8.030. Okay, because when we're trying to round this up, this became 10, and of course we can't use 10, so you have to go over to 2, so it became 30. Now let's look at this one. This one is a bit tricky, but you have to be very careful. When you want to represent this to one significant figure, okay? Now, when you round this up to one significant figure, now we're not counting, we won't count this 0, we won't count this 0, we won't count this 0. We'll count the first value we see, okay? Non-zero value. So, but we'll still maintain the place values of the zeros. So we have 0.009, okay, to one significant figure. And 2 significant figures, we have 0.0093. So it's very important, whenever you're dealing with numbers like this, you don't count this as significant figures. So let's look at decimal places. When you're rounding off to decimal places, you just start from the decimal points. And it's very easy. So if, for example, you have 12.9348, okay? And you're supposed to round up to the nearest, to one decimal place, sorry. One decimal place, you have 12, that means you're interested in just this first one, 12.9, especially because 3 is not up to 5, okay? So to 2 decimal places, you're interested in these 2, you have 12.93. And for 3 decimal places, you have 12.935. So if we have this 1.9875 to 1 decimal place, we have 1 point. Okay, it won't be 1 point because now this 8 rounds up this to 10. So 10 carries 1, goes over here. So to 1 decimal point, you have 2.0. Okay, so to 2 decimal points, we're interested in these 2. This one rounds up to this. You have 1.99. And to 3 decimal points, you have 1.988. So looking at this, 0.0089. Now, that significant figure rule does not apply here. Okay? To 1 decimal place, this is, we are going to considering this 0 is 0.0. Okay? 2 decimal places is still 0.0. This one rounds up to this 1. Okay? And 3 decimal places, we have 0.009. I hope you learned something new from this video. Please try as much as possible to solve as many questions as possible. If you have any questions, any comments, any queries, don't hesitate to use the comment section. Please like, share, and subscribe to my channel. Thank you.